access certain resources. And there's an update process. So normally, a browser will, every time you visit a website, it will check your manifest file. If the manifest file is unchanged, then nothing will happen. But if the last modified time is changed, then the browser will fetch the manifest file and then read the list again, and then re-download all the resources again. All the resources in the cache section again. Okay? But if you want to perform the update process yourself, for example, your server is telling your browser, hey, I just released a new version, then you can use JavaScript here to perform the update yourself. So you simply need to access the application cache object, call the update method, and then wait for this update ready event. So when this update event fire, it means that all the file has already re-downloaded to your browser, or if there is an update. If there is no update, then this event will not be fired. Okay? And after the update ready event is fired, you can simply call the swarm cache. But after you update and swarm cache, it simply means that these new files are downloaded to your browser. They are not yet visible. You need to, for example, we could pop up and confirm to ask the user, hey, I just updated, there's a new version, would you like to refresh your browser? Then if the user press yes, then the browser will reload the new version. Okay? So this is a manual update process. And browser support is really good. IE, Firefox, Chrome, Safari, even in mobile side, the iOS, Android, they're all supported. So you're encouraged to use this new technology. Any question about the offline app cache? Yes.
Is there a limit to the files that you can download? Is it based on the storage?
I remember there is one. It's also some megabytes or something, but it's quite enough for you if you were just catching some JavaScript, CSS. They are not so big, so it's quite enough for every site to store these data. Okay, this file. Okay. Welcome.
Continue to that question. In terms of speed and server load, I think the majority of the workload is the image. So static image.
Static image, yes.
So once the storage limit is not that much to store an image, I don't think that will be really helpful to the server.
So you mean that the browser has limited storage, so it's not so useful, right? But the app cache is not for storing the whole website. Okay, it is used for example, I have some key file that, for example, the index HTML, the JavaScript, to make sure the website could show up to you, okay, show to you, but not catching the whole site, so that when there's no network connection, I can still show the user something, okay. And later, the next section, I will talk about the online-offline event, so that you can actually detect the user's online-offline status to combine with this, so that if you have no network connection, the user will just see a browser saying that you don't have a network connection. You can still see something, kind of like a client app. A client application is directly downloaded to your computer or mobile phone, right? Even you have no internet access, you can still see something, right? Any more questions?
I wonder if you can also store elements in HTML, like within the file, like a div or something like that.
So you want to put a part of the
HTML that is repeating other files, but I want to store that element.
So you want to use it like a component, right? So that you can reuse it. No, this can only store a single file. Okay. But you can separate these components in different files. Okay. Yes.
If the client turn on the privacy browsing, will it work?
Privacy?
Privacy routing, like they don't allow to
Or like the crumbs in other mode? Yes, it will still catch it. But in separate places, right? They're completely separate. They won't affect your normal browsing section. No questions? Okay. So let's move on to the online-offline event. So this event, as its name suggests, will fire when you're online or offline, when you lost connection or connected to the internet. And there is another attribute that you could access the current status. You can ask the browser, hey, am I online now? So let's take a look at this one. You could ask the navigator.online, so it will return true if you are online, or return false if you don't have an internet connection. And this is how we listen to the online-offline event. You simply add an event listener to the window object, and then do something when this event are fired. So the online event will be fired when you connected to the internet, and the offline event will be fired when you lost connection. Let's take a look at the demo. I believe it's this one. Yes. Now I'm online, of course. And where's my? Yes, here. Now I'm gonna turn the Wi-Fi off. Watch. Now I'm offline. Okay. The browser could actually detect this status and then tell me I'm offline now. Now I'm going to reconnect to the Wi-Fi again. Hopefully I can. Okay. Now I'm online. So this event is very useful if you care about this status, and then you can show tell the user, hey, you're offline. You just reconnect to the internet. Okay. So in this section, we just learned how to use an application cache and then how to listen to the online-offline event. Again, if you want to read this code in more detail, you can just open this website, and all the codes will be inside. Okay, and there are some comments you can read. And here, next section, we're going to talk about file access. So before HTML5, there is actually no way for a browser to access the local file, except that if you are using plugins like Flash or something. And the ability to access local file is really important. For example, you are creating a Photoshop for the browser. Then you're creating a Photoshop right in the browser. I want to modify the user's image. So what do we do before this final API? We select a file with a file input, and then upload that file to our server. So our server will give our URL to load this image, and then we load that image again, and then in the browser, so that we could do a little manipulation there. But now we can actually access the file object itself. When the user selects the file, we can read its file name, some other attributes. We can read the file's content, and then we can save it back to the local file system. It's really, really useful if you are creating some web app. So there's a few objects that you would like to know about to work with the file object. There's a file which represented a file object, and then the file list. For example, we are selecting files with an input control, and that input control allows you to select multiple files. So when you select file with that control, it will return a file list, which is simply an array of file object. Okay, and then the file reader is used to read the content of a file. We could use that to manipulate the file. For example, we can read the image, apply some filters on it. And the blob is representing the content itself. It's like a bunch of data. Okay. And let's take a look at the demo here. Please, this one, yes. Now I have a little control here. You can take a look at the CSS code. It's quite simple. Here we have an input called a file, and we specify multiple so that you can select multiple files. And then there's an output here. This output is later our JavaScript will populate it with the information of the file. So here, when we click this file object, we can access, for example, this file in my desktop. Select it. Boom. The file name, type, how big is the file, last modified date, and a lot of other stuff. You can all read this information right into the browser. Doesn't need a server to do this, right? And also, if you want to improve the user experience, you don't want a little control there. And then let the user click, find the file, then this not natural interaction. So we want the user to just drag their files, drop in your browser. You can also do that by drag and drop. Let's go back. Now again, it's the same tool file over here. Select it, drag it right here, and then again, it's the file's information. So there's two ways. So you can use a file control, or you can use drag and drop. But drag and drop, I believe, is not actually useful in a mobile device because you don't actually drag a file on your mobile phone, right? Okay. Can you see it's clear? And after you select the file or drag the file into your browser, you can access the file object. Then you could actually create a file reader to read this file object, and then to access its content, to do also all type of manipulation you like. And for example, here we want to. This one, please. And also you can apply that access attribute to this input control, this file control, to say that hey, I only want to read some image file. I don't want to load any other files. So we could specify the image here for the accepted accept attribute. So take a look at this. Now note that this PDF is grayed. I cannot select it. With this image, I can select it, type open, and then read the content of this image, and then create for example, an image tag, and then apply the content to that image tag so that I can just show the content. Okay. And browser support is also really great. You can use Firefox, Chrome, Safari, Opera, but not IE yet. But it's quite already enough for the they use, because actually quite a lot of user is I guess is abandoning IE, right? Although IE said that, hey, my IE 10 is really great, try it, man. And then file system API is a different type of file system. So in the previous example, the user have to initiate the actions to select a file, either by clicking in file input or drag and drop the file. This is all user initiated actions, right? But for example, I have a quite complex data, or I just want to store some text file. I don't want to put in the web storage because it has limited quota, right? I want to store my file in a quite big file, so I can use this file system API. I could actually access a sandbox section of the browser. I can create file in it, I can create directory in it, and I can manipulate them, read them, write to them, copy, move, anything you can imagine in a file operation. So this is how it looks like when you are here. We need to request a file system. We will ask the browser, I want a section, I want some file storage, I want to store file. Here, there's actually two types of file system. There's a temporary one, which is not reliable. When the browser is running out of storage, it can remove it anytime. And the persistent one is something that will persist in your file system. The browser will not remove it, but this one will require user authorization. The browser will actually pop up a little tips to ask the user, hey, this website wants some storage from you. If you allowed it, then the user could grant it or deny it. So here, this is an example of requesting a persistent storage from the user. There is a request quota here. We need to invoke this function to say that I want some persistent storage and how big I want it to ask the user. So after the user granted, we could say that this on-init file system function will be called so that we could continue our file operation. Or if the user denied it, then this function will be called. Then maybe you could do some error handling, say that the user has denied my access. And there is actually 4 basic operations for both files and directory. There's create, you want to create a file or create a directory. You want to read it, you want to write data into it, and then you can remove that file or directory. Okay. Now, all these are actually code samples. You could take a look at it on the hands-on lab sections or when you have spare time, right? I'm gonna skip all this code. Boring. Oh, this is another one. So just keep in mind that everything you can do with a browser, with a file, this file system API can do it. Creating, reading, writing, removing, copy, move, rename, everything. Okay, and sometimes I want to reference that file. I want to see that file from the browser. But without JavaScript, okay, I can generate a URL. Something looks like this. So a normal URL would start with HTTP and then the host name and then the path. But this one has a prefix called the file system. So this represents a file in the file system you store to the browser. And then if you visit this link in the browser, then you can access the file. For example, we're storing an image in the file system, and we could use this link as the source of an image tag to show that image to your page. Okay? Oh yes, and there's a little demo here. So this is basically like a file system. And type help. What do I have? Oh, too much. Now you can see that list of files, move them, open them, remove them. So let's see what file we have. Oh, nothing. Oh, we have a phone folder. Let's see what's inside. Nothing. And is that F file I'm dragging from the desktop? Okay, I'm going to drag 2 files in it. Okay, file that. Actually, just 1 file. I guess it doesn't support multiple files. Let me drag again. Invalid notification error. Never mind, we already have 1 file. And we can remove it. Gosh, this is a long name. Not file. I guess the name is wrong. Yes. And look, this PDF still left there. So this kind of like a web console that meant to operate file. You could try it. It's quite fun. So, but this new API is not actually quite fully implemented by the modern browser. You can see that Chrome is supporting it, but not Safari, and Firefox is partly supporting it. So if you want to use it, maybe you could just think about what's your target user, how do you deal with, for example, Safari, which does not support this system. Any question about the final API? move on to the next topic. Here we talk about web workers. Web worker is really quite exciting. We have been asking for multi-threads for JavaScript for a long time. It just added to HTML5. And why do I need multi-threads? For example, I have a very heavy computation. I want to compute a lot, and it would gonna take a lot of CPU time. And if you do it with JavaScript without a web worker, it would just block, it would just frozen your user interface. Nothing would react. So if you, for example, the button won't react, you can scroll the page. So it's a really good way that you want to put some heavy operation inside these web workers. And also, inside the web worker is simply running a simple JavaScript file. It's actually the same. You just put a JavaScript file running in a background thread so that it won't influence the UI. And because it is in a different thread, this JavaScript in the web worker cannot access the DOM. So that maybe you could do something to protect the DOM. Later I will show you an example. Okay. The API is also really simple. You need a worker, ask him which file to execute, and then it would load this file and then run the JavaScript in its own thread. Okay? And post message is if you want to interact with the worker, you want to tell the worker something, or you want the worker to return you something. There's only one way, by passing messages. So you could post message from your main thread, and if you have some results from the web worker later, then he could post a message back to you. Okay, this is the like a message channel. We can talk to each other. And this is a simple example. For example, we have a main script running in your page, and then it would actually create a new worker and run this do something JS, and when they receive message from that worker, it will say that a worker just said something. Okay? And in the worker, it is waiting for a message when it is loaded. It runs this script and then it's waiting for a message to do some heavy work. It will take some time, just maybe very heavy computation. It takes something like 10 seconds, and then it will post the message, the result, back to our main thread. Okay? This is a simple example about how to use it. And if you have some simple code, I don't want to put in a separate file, you can also create something called an inline worker. You could just create a code, write a code here, which is the JavaScript you want to run in a web worker, and then simply just start it without a separate file. And let's take a look at an example. Here we are going to find a prime number. You guys know what a prime number is, right? And this is the description here. Okay? And we are going to find it from 1 to, what is it, 200,000, I guess. Now, let's take a look at it. If we do this computation without a web worker, what does it look like? Now, this is a little GIF animation here. If I start with a worker, everything stopped. I cannot scroll my page, I cannot access anything, oh, there it is. Now it comes back. It says that it finds 17,000 prime numbers listed here. But the important part is that during the whole process of finding this prime number, the UI is frozen, it's not responding anymore. I cannot do anything to stop it, for example. But if we have a worker, let's see here, same number, same JavaScript, but put into a web worker. Let's see what, when it starts, yeah, this is still turning. We can scroll the page, we can modify something. And all this heavy computation is done. It's doing in the background without influencing the main UI thread. And there's no DOM environment, like I said, because it is running outside the UI thread, so the JavaScript in the web worker cannot access the UI. So how do you use it? actually we create a game called Code Tank on the web. So programmers could write codes to control their tanks to fire to each other. Yeah, something like this. You go create your tank, put it in the field, and then battle together. But some guys get smarter. Hey, why bother the algorithm? I don't care. You see those little tanks here? I can access them with JavaScript. They're simply DOM elements. I can access them. I can modify their attribute. For example, I just let them loose. So I'm always a winner. So how do you prevent these kind of tricks? So the thing we've done is that we put the users create JavaScript code, put it in the web worker to run, to control their tank, so that these codes cannot access these UI. So it's pure algorithm things without the tricks. Okay. And also the browser support is very, very good. Firefox, Chrome, Safari, Opera, everything. Any question about this section, web worker? No? Okay. Now this section is about, this topic is about communication. So there is actually a few ways if you want to communicate to a backend or even to for example, in a P2P connection, but this is actually not yet standard. So I will just show you some sample, but not the code, okay? And the most common way we try to communicate to the server asynchronously is issue the XML HTTP request, which in short is XHR, which is hard to read this name. Or if you use some real-time push message, for example, we are creating an instant messaging for the web browser. I want to fetch message. I don't want to send a request to ask the server, hey, do I have a message? And then send a request again, do I have a message? Do I have a message? Do I have a message? With web workers, you can do something like a server push. You create a WebSocket connection between the client and the server, and then you could do bidirectional full duplex communication. You can send message to the server anytime, and then the server will push you back message anytime. It's kind of like a socket. So XHR is just XML HTTP request. It's the way we send asynchronous HTTP or HTTPS request to the server, so that we can fetch some data from the server without reloading the page. And this is how you do it. You create a new HTTP request, tell it which method. You can use get, you can use post, something like that, and then the URL you want to fetch data from. And here there is something called the on-ready state change. So when the XHR fetch the data from the server, this event will be fired. So they will do something with the data. For example, the response text would be the data returned from the server, and then you simply send the request out, okay, and then wait for the result. And in XHR level 2, it actually doesn't use this name anymore, so they merge this level 1 and level 2 into one specification. Because in the old standard, there's no way to handle timeout if the server responds too slow or the network status is bad, and it could take some time to travel back to the server, right? And if you want to handle a timeout, you need to set a timer yourself to check, for example, for 10 seconds, and then say, oh shit, the result is still not yet come back, so there's a timeout. Or monitor the progress. I want to see, for example, we are downloading a very big file. We want to see the progress. We want to see a progress bar on it. And there's also an issue called the cross origin.